Alright, so hi everyone. Today we will be studying force, pressure and density, the example session. Alright, so in the example session we will be having multiple choice questions and along with answers which will help you better prepare for the assignments and for practicing. Alright, so let's start. Alright, so our first example, when applied force on an object is doubled but it remains at rest, then the friction becomes how much? If you remember in the class I have told you, supposedly I am applying a force of 50 Newton in this direction. So that my brick does not move in this direction, I need to have an equal and opposite force, which is friction. Alright, but for it to be equal, it will be 50 Newton. Now they are saying, supposedly this force that you were initially putting is doubled. Now it's 100 Newton in this direction. To keep it at rest, how much should be the friction? It should be 100 Newton, right, in the opposite direction. So the friction has also doubled. So friction has doubled. Answer is doubled. It is easier to swim in sea water because sea water has waves. Sea water is more dense than river water or any normal water. Sea water is less dense. Sea water has a lot of water. Alright. Sea water, it's easier to swim in sea water because it is more dense. By more dense, it has more salts, more molecules, more things in it. Sea water is more dense. It has more dense. Bar is a unit of, now we've come to pressure. What is bar? If you remember, bar is a unit of pressure. Alright. Next question. In the following, identify the agent exerting the force and the object on which it acts. Alright, so there will be a case, someone will be putting or pulling a force, exerting force on something, okay, and you have to tell who's putting it, on what he's putting it, state the effect of each force. Alright, so what is happening? For example, squeezing lemon with the fingers to extract its juice. We've all seen everyone squeezing a lemon. Alright, to squeeze a lemon, you use your fingers, you put muscular force. You put muscular force, the shape of the lemon has changed. Alright, we exert muscular force to squeeze the juice out of the lemon. As a result, the shape of the lemon gets changed. Alright, now who was putting the force? We are. On what? The lemon. Alright, what happened? Lemon gets, the shape of the lemon gets changed. Alright, yeah. To press out paste, pressing out paste from a toothpaste tube for brushing. Alright, every morning you brush, you take out toothpaste, Colgate, Pepsodent or anything what you use. Alright, you take out toothpaste from it by pushing it. Alright, supposedly this is your toothpaste, you are pushing in this direction and it comes out like this. Alright, on your toothbrush. What is happening? You are putting force, again using muscular force, pushing it on what? On the toothpaste. What happened? Shape is changed, right? So shape gets changed. Now third part, a load suspended from a spring while its loose end is on a nail fixed to a board. I'll tell you something. Supposedly there is a nail. What is a nail? We use a hammer, right, to put it into a board or a wall or something. So there was a spring attached to some load, okay, some weight. Now this is heavy weight. So what will happen? It will stretch. The nail on which this will stretch long. This will be like this. Alright, what has happened? The load is exerting some force. After putting some force, the shape of the spring is changed. An athlete running and making a high jump to clear a bar that is at a certain height. Alright, if you've seen athletes, supposedly this is a pole. Alright, the athlete has to jump over it. It will charge towards this, run towards it, exert some force on the ground and he will go up. So what is happening? Who is exerting the force? The athlete. On what? The ground. Alright, what happens? He goes above it. When depth in a liquid increases, what happens to the pressure? If you remember, I have taught you like this, right? Supposedly this, there is a liquid in here, alright? Pressure will be different at this point, pressure will be different at this point, pressure will be different at this point, alright? A, B, C, P1, P2, P3. Pressure will be different at different heights, alright? Different at different heights. As we go down, the in depth of the ocean, in depth of any material, pressure will be highest. Pressure. Alright, highest pressure. So pressure increases. Mountaineers suffer nose bleeding due to what? Supposedly there is a mountain. Alright. Snow mountain. Okay. Someone is a mountaineer. He climbs up over here. Okay, he's here. Atmospheric pressure is less. Atmospheric pressure is less. But his blood pressure is very, very high. Alright, sorry, high. Blood pressure is very high. As a result, blood starts to come out of his nose. It finds a way to come out. This is low atmospheric pressure and high blood pressure. Low atmospheric pressure, high blood pressure. Which of the following is not a contact force? Forces are of two types: contact forces, non-contact forces. Alright. Contact forces, muscular, frictional. Non-contact would be magnetic, gravity, electric, electrostatic. Alright. So over here, which is not a contact force? Friction, magnet, tension and gravitational force. Actually, both gravitational and magnetic force are not contact forces. Okay, so we can add over here and gravitation. Pressure is defined as what? If you remember in class, P is equal to F upon A. It is force upon area. What is mass per unit volume? It is density. What is velocity per unit time? You will learn that in motion. Alright, velocity per unit time is speed or direction upon acceleration. Energy per unit charge. You will all learn this. Which of the following units is used to measure pressure? What do we use to measure pressure? If anyone remembers, barometer. In what terms? The SI unit to measure pressure is Pascal. Newton is force, joules is work done, watt is power. SI unit of force is Newton. When a force is applied to an object in the direction of its motion, it results in what? Alright, so I'll tell you, supposedly in the class as well, I told you, your friend is cycling in this direction and you give him a push. Don't push him, but if you give him a push, he will go faster. You have added on to his motion, you have added on to the force he was exerting. So it will be increased speed. Which of the following is an example of a non-contact force? Friction, tension, gravity, magnetic. Again, it's magnetic and gravity. Alright. Force exerted by a fluid on an object submerged in it is called, if you remember, this is water, there is a person who is swimming, okay, he is immersed. Immersed means dipped or floating or submerged, okay, into the water. There is some level of displacement of water, there is an upward thrust to it. What was it? Buoyant force. Okay, weight of an object depends on its mass. Which of the following statements is true about pressure in a fluid? It decreases with depth, it increases with depth, it remains constant with depth, it depends on the temperature of the fluid. It does not depend on temperature, it increases with depth. If you see in sea, supposedly this is the sea, alright, there is a submarine, okay, there is a submarine. Submarines are designed in such a way that they can handle a lot of pressure, because in depth there is a lot of pressure. Alright, so and scuba divers suits are designed in such a way that they can handle the pressure. Alright, it won't tear. At depth there is a lot of pressure in fluids. The density of an object depends on its, what is density? Mass by volume. Alright, if you remember m by v, what does it depend on? It depends upon its mass, it depends upon the volume as well, and volume. Which of the following material is most dense? Alright, so solids are more dense than liquids, alright, so we can exclude this. Okay, wood, aluminium and iron. Okay, amongst this, which is the most dense? Iron is, alright, it's the heaviest among these. Aluminium is a metal, but it is also light. Okay, it's a light metal. Wood, but we all know iron is heavier than wood, metal is higher than wood. Okay, the pressure exerted by a gas depends upon what? Its temperature, its volume, the number of particles present, or all of the above. It is all of the above. Which of the following factors affects the buoyant force on an object submerged in a fluid? Okay, so buoyancy is the tendency of a liquid to put an upward thrust to whatever is put inside it. The density of the fluid, the volume of the fluid, the gravitational force acting on the object, everything, every single thing will affect the buoyancy. Okay, so answer is D, all of the above. Which of the following is a scalar quantity? Okay, which of the following is a scalar quantity? What do you mean by scalar? Alright, I haven't taught you this. Scalar means without direction. Okay, without direction. Which of the following over here is without direction? Okay, force is in a particular direction. You push or pull in a particular direction. You push on the ground in a particular direction. Velocity is speed with the direction. Alright, so something is going in this direction with speed, in this direction with speed, in this direction with speed. It has direction. Acceleration, of course, when you are driving a car, when you are driving your motorcycle, it is going in a particular direction with some speed. So only density, if you remember, okay, I told you guys, supposedly there is some volume and there is some density as well. Okay, there are some molecules inside this cube. It is density. Okay, it has no direction. Yeah, hi. So for our next question, which of the following equations relates force, pressure and area? If you remember the formula, P is equal to F upon A. Alright, this is the basic relation between all of them. Okay, this is the basic relation. P is equal to F upon A. Over here, force is equal to pressure into area, pressure is equal to force into area, area is equal to force into pressure, pressure is equal to force into volume. There is no volume into play. What we can do here is F or P multiplied by A. This goes over here, it's in division here. It goes here, it gets multiplied, is equal to F. P into A is equal to F. So force is equal to pressure multiplied by area. Where is it? Force is equal to pressure multiplied by area. Answer is option A. Now, the hydraulic lift works based on what? Alright, if you have heard about the hydraulic lift, it is putting a pressure. Okay, it is something that puts pressure. Okay, it's based on Pascal's principle. Pascal, if you remember, you can also relate by Pascal What is Pascal? It is the unit of pressure. This was the guy who discovered pressure. Okay, so Pascal's principle. A body will float in a fluid if its density is what? Okay, for something to float over water, okay, for something to float over water, what should be the density in comparison in relation to the water? Okay, less than the density of the fluid, equal to the density of the fluid, greater than the density of the fluid, or unrelated to the density. It should be less than the density of the fluid. If the density of this substance is more, it will sink. If it's less, it will float. Okay. The principle of conservation of mass states that the density of a substance remains constant, the total volume of a substance remains constant, the total mass of a substance remains constant, the total weight of the substance remains constant. You should know the principle of conservation, alright, in the lectures. It says the total mass of a substance remains constant. Alright, you will come up with this example again and again in many lectures.